So this is the second review question that I have for you. So we're determining again the centroid of a thin plate. So looking at these, our first step is to determine which parabola is which. So I know that the one pointing down is going to have a negative x value. So this one must be my y equals 4 minus x squared. And this one must be my y equals x squared plus 4x plus 4. And I'm trying to determine the centroid of that bound area there. So my first step is going to be to calculate the limits. So in this case, I'm going to try and find a value of x. So it will be where those two lines intersect. So I have x squared plus 4x plus 4, and I'm going to set it equal to my second parabola there. I'm going to bring this value over, making it a plus x squared. And x squared plus x squared gives me 2x squared. And then I'm going to bring this over, which is going to become a minus 4. Just going to cancel that one out, leaving me with 2x squared plus 4x equals 0. I notice that there is a factor of 2 and an x on each of those terms. So I'm going to factor out 2x, which leaves me with x plus 2. So I know my first x is 0, because no matter what value I put in this bracket, because that first x is 0, the rest of it's going to be 0, because 0 times anything is 0. And the second bracket gives me x is negative 2. So that must mean that this is negative 2, and this is on the y-axis, giving me 0. So my second step is to calculate the area. I'm going to calculate the area of that plate. So I use my area formula, again from negative 2 to 0. My y2, my top one, is actually the parabola that goes down, is my top line. So that is going to be 4 minus x squared. And I'm subtracting that from my second parabola there. Now this question is going to be pretty heavy in your algebra, so you need to make sure that your negative signs follow through. If you need to do some algebra on the side and not within the algebra formula or the area formula, then that's perfectly fine. So I'm going to simplify this. I see that I have a 4 here, a minus another 4 here, so they're going to cancel each other out. So that leaves me with negative 2x squared, because I have a minus x squared, and minus 4x. Okay, so if I integrate that, I end up with negative 2x cubed over 3 minus 4x squared over 2. And you know I like to always simplify as much as possible before trying to substitute any numbers in. So this first term can't simplify. The second term, 4 divided by 2 is 2, which gets rid of one of the fractions, which makes it a little bit easier. So with my 0, those are both going to be 0 because I have two x's, but I'm still going to write that down because I'm subtracting a term. So subtracting something. And I end up with 16 over 3 minus an 8. Be careful of your negatives there. which leaves me 8 over 3 units squared. So my third step is to calculate my moments. So my my, I'm integrating from -2 to 0 again. I have my x term out front, and we know from our area that it simplifies down to minus 2x squared minus 4x, so I'm going to use that over here when calculating my moment. Okay. So I'm going to multiply the x through, which gives me minus 2x cubed minus 4x squared. And if I integrate that, I get negative 2x4 over 4 minus 4x cubed over 3. I'm going to simplify that because I know 2 divided by 4 is a half. So that first term again is going to be 0, but I'm going to write it out. The second one gives me negative 16 over 2 plus 32 over 3, which leaves me with negative 8 over 3. And again, I'm getting a negative answer, so I'm going to just double check that that makes logical sense. So if I look at my graph here, I see that my flat plate is in the negative x coordinate. So that makes sense that my moment for my x value is going to be a negative number. So that's okay that, that it's negative. That's perfectly fine. So now looking at the mx, this one is pretty intense with algebra because we're going to be squaring both of those terms. So if you need to square them on the side and then bring them in, that might help you out. But we get half negative 2 to 0 and I'm going to square my y2, subtract the square of my y1, so when I square this first term, I get 16 minus x squared plus x to the power 4. This next term is pretty long, but you end up with x4 plus 4x3 plus 4x squared plus 4x cubed plus 16x squared, 16x plus 4x squared plus 16x plus 16 and that all simplifies down to negative 8x cubed minus 32x squared minus 32x dx. Again, I would suggest doing this on the side of some rough work, not forgetting that this negative symbol is there, so it's going to make all of the terms in the second bracket negative, or change their sign anyways. So be careful that you don't forget that. So if I integrate this, again the half just tags along, and I get negative 8x to the power of 4 over 4 minus 2x cubed over 3 minus 32x squared. The 0 is just going to be a 0 all the way through, but I'm going to write it down. The second term gives me negative 32 plus 256 over 3. Put that as a fraction, not as a decimal. You don't want to have to round too many times. It makes your answer inaccurate at the end. Keep everything in fractions. End up with that, which equals 16 over 3. So now I have my two moments. I have my area. So I'm going to use all of this to write my final centroid. So your last step is your centroid. So your x value is going to be your my divided by the area. You end up with negative 1. And your y is going to be your mx divided by your area. Which gives you 2. So all together, you end up with negative 1, 2. And I'm going to go back to my graph, make sure that makes sense. So that would put my point, negative 1 there, 2 is there, so it's going to put your point right there, which makes sense. Because again, because it's just a thin plate on a graph, it's going to have uniform mass. So the middle point of that shape makes sense that would be our centroid right in the center. So that's a good check to do to make sure that your answer is correct.